Okay, so we can start with the introduction talk, I guess. Okay, so welcome everybody to Pass the Salt 2021. This will be our fourth edition for the Pass the Salt conference and the second virtual edition. So due to the ongoing pandemic circumstances, of course, we had to switch to an online event once more. So well, the bad part is that we won't be able to meet face to face in Lille in France. But the good part is that you can enjoy the conference how you like it, either from home, from office, from your holiday, from the beach. You can do what you want. So without further ado, what can we tell about this year's conference? So we had 27 proposals, 27 talk proposals, which is a good number for us given the circumstances. We accepted 16 talks amongst these proposals, and so we were able to establish a schedule composed of 3 afternoons with roughly 5 talks per afternoon. So this will be today, tomorrow, and Wednesday, of course. Then look at the audience. So we can compare where people come from, where the audience come from. So with the last event that took place in Lille, we had a significant part of the audience that originated from France. And with the online edition, we can see that it's distributed more equally among the rest of the world, and in European Union and outside of the European Union. So that's a good point. Then about sponsoring. So for this edition, the sponsors are, so for the platinum sponsors, we have Vates, which is a provider of virtualization open source solutions. And we have Rudder, which is a tool to manage configurations and verify the conformity of configurations. So these are our 2 platinum sponsors. We have 4 gold sponsors, which are Google, that I won't present. Quarks Lab, which is a French IT security firm. We have the ANSSI, which is the National IT Security Agency in France. And we have the French bank, well, the international bank, Société Générale. And then we have 1 silver sponsor, which is Synactive, another French IT security firm. We also have partners, so these do not provide direct funding, but they provide useful services to us. So we have Predix, which is our registration system for the conference. We have the University of Lille, which has provided us with Zoom access and the ability to create the Zoom webinars. And well, usually the University of Lille is the university that hosts the conference. But well, there is some kind of continuity here because the university has provided us with the Zoom access. And finally, UBcast. UBcast is usually our streaming platform for the conference. So they film the conference and then they broadcast it. But for this year, as we use Zoom, we have Zoom streaming and YouTube streaming. And at the end, the talk recordings will be hosted on Libera.chat. And you can find also on Libera.chat the recordings for the previous years. Then just a quick note about our expenses. So of course, with an online conference, and as the Zoom access is provided for free, we have very little expenses for this year again. So no travel reimbursement. We didn't have to pay for the reimbursement of our speakers. No on-site communication, no catering, which is also a big expense point. Also, no goodies again for this year. No stickers, no shirts. So very little expenses. And with this fact, we our sponsors will stay sponsors for the next edition of the conference, as their funding will still be available next year. So all the sponsors that I presented will be sponsors for the next edition, but we always welcome new sponsors. As for example, Rudder was not a sponsor last year, but is a sponsor this year. So they expressed their interest in sponsoring us during the beginning of the year. So we always welcome new sponsors, of course, in the hope that we will finally be able to have our next conference in a real life event in Lille this time. So regarding the talks, you will be able to interact with the speakers. You can ask questions through the Q&A system on Zoom if you have registered and if you have got your Zoom links. So at the end of their talks, the speakers will look at the QA box on Zoom and will answer all the questions that you asked. You will also be able to ask questions on IRC with the Libera.chat platform on the hashtag PTS21 channel. And finally, you can also use the Twitter hashtag to ask questions via Twitter. Okay, so this will be the end of the introduction talk. If you have any question you can, about this introduction talk, you can of course use the Q&A box on Zoom. And well, if there are no questions, we will have just a quick timer before the first conference. And the first conference will be given by Eloi van der Beken about jailbreak detection mechanism on very a particular phone system, but I won't spoil. Okay, so thank you for listening to the introduction talk, and well, we will wait for the beginning of the first talk. Okay, Eloi, maybe we will leave the timer for just a few minutes before the beginning of your talk. I don't know if Philippe
Okay.
can put the timer back.
Do you hear me?
Yes, that's all right.
Should I start?
You can wait just 2 minutes more.
Okay. I've got some problems with Zoom, putting bars everywhere.
Yeah, Okay, so it is time for the first talk. So I will let Eloi van der Beken speak about so jailbreak detection mechanism and the bypass. So he's from Synactive, one of our sponsors. Thank you, Eloi, and you have the mic.
Okay, thank you, Mathieu, for the introduction. So as Mathieu just said, I'm going to talk about jailbreak detection mechanism and how to bypass them. But first of all, let me tell you a little bit about myself and the company I work for. So I'm Eloi van der Beken, and as Mathieu said, I'm working for Synactive, an independent offensive security company. We're divided in 3 different departments. So the pen test one, which focuses on everything that can be intruded. The development department, focusing on the development of internal and offensive tools. And finally, the reverse department I'm working for as a tech leader. So in the reverse department, we are working, we focus on, well, reverse engineering, obviously, but also low-level development, vulnerability research, and exploitation. So we work basically on everything that contains software, from a bootloader to trust zone, kernels, routers, application servers, browsers, well, really everything. So in the whole company, we are 90. In the reverse pool, we are 30. And we are hiring, so do not hesitate to contact us if you want to work with us or if you want to join us. So now that you know a little bit more about me, before jumping into the technical details and the technical case, let me first introduce the subject. So jailbreak detection. So I guess everybody here knows that iOS is a mobile operating system developed by Apple. So for various reasons, both security and economic ones, because Apple wants you to pay for your apps and they want their share on the buy. The iOS system is closed, so there is no easy way or built-in way to get root on iOS or to manipulate arbitrary applications. Fortunately for us, jailbreaks exist. So jailbreaks try to bypass all the security measures put in place by Apple to give you full control on your device. The problem is that not everybody likes jailbreaks. For example, banks might be afraid that a malware could take advantage of your jailbroken phone to get access to the secrets they store in their app, and for example, to steal you money or do nasty things. But also game developers will also want to protect their application against cheaters or bot developers, because it's way easier to develop, to create and to exploit a bot on a jailbroken device. So they will try to detect if your phone is jailbroken and will block their applications until they consider your phone to be clean enough. The problem is that we, as a security folks, also need to study applications, for example, to ensure that data is well protected, or to create an independent client, for example, or also to find out how data is stored in backups for a forensic purpose, for example. So, ends this presentation. But before talking about anti-jailbreak protections, we need to talk about iOS specificities that application developer and security researchers have to deal with. First of all, in iOS, everything must be signed. The code must be signed or your application will be killed by the kernel. For the data, it's a little bit different. In theory, you might have unsigned data in your application. The kernel doesn't block that, but Apple makes sure that's not the case when you submit your applications to the App Store. And the App Store is basically the only store where you can get your app on. The second specificity stems from the previous one. It's impossible to create executable memory, which is also writable. Otherwise, it would be trivial to execute unsigned code. The only exception are if your process is being debugged, but that requires special entitlements, as we will see later. And if you are the web content daemon was in charge of executing JavaScript code. So to compile JavaScript code on the fly, they need to have read, write, and executable pages. But only the web content daemon has this power. The other limitation is that you cannot have side loading. That means that applications may not download, install, or execute code which introduce or change features or functionality of the app. That means that you cannot, for example, try to detect a jailbreak, and if you detect a jailbreak, close the application. Otherwise, download the rest of the applications. What does that mean? That means that an attacker always have all your code. You cannot hide any portion of your code, either by encrypting it or either by downloading it when you need it. So this means no layers of encryption, no auto-modifying code. Your code must be in plain sight. The other limitation is that you are not supposed to use private APIs. You are limited to public API only. Why is that? It's because Apple doesn't want you to use APIs that they will want to change later. They only want to support limited limited number of API. So this is enforced during the App Store review via automated checks, but actually it just blocks some malicious tracking methods or deprecated APIs or codes that do not want you to use because they are planning to change it. It's not that enforced. It's just that if you are using private APIs, well, your code might crash in future iOS versions. Okay, so we've talked about iOS limitations. Now let's see what we have in our tool bag. So the most powerful tool available on iOS is Frida, that you probably already know. Frida is a dynamic instrumentation toolkit. So basically, it allows you to inject arbitrary JavaScript into a process and instrument it. By instrumenting it, I mean hooking its functions, dumping its memory, create new Objective-C objects, for example, or intercept method calls, etc., etc. So Frida has a lot of features, support almost all the operating systems, being from a server point of view or a client point of view. It also have it has also a lot of bindings and a low-level C API, which is really handy if you need to build standalone tools that need to inject themselves in applications or processes. The good thing it's open source and it's really well coded. Oliavre, I don't know if I pronounce his noun well, but Oliavre, the project benevolent dictator, make personally sure that every commit respects the project guidelines. For example, I once did a pull request that had more comments from Oliavre than lines of code. So well, it's really well coded, and it will stay that way, I think. You probably also have heard of Frida at Libera.chat in several past talks, and you will heard of it in future talks, if I'm right, at this session of Libera.chat. The only little problem with Frida is its documentation is not really easy to read. It's just a big HTML file with a lot of lines and a little index, but maybe as a result of this, some of its functionalities are not that well known or nor used, although well, very powerful, as we will see. So last but not least, why do we want to jailbreak our phone in the first place? So Frida does indeed also work on non-jailbroken phones, and you can also debug your applications with LLDB, the iOS and macOS debugger. The problem is that to use Frida on non-jailbroken iPhones, you only have two choices. You can inject Frida with ptrace, but your applications will need to have the get task allow entitlement, because without this entitlement, you will not be able to attach to the application, and this entitlement is never present in the applications on the App Store, as its only legitimate purpose is, well, to debug your own applications. So you can't have this entitlement in App Store applications. You can also inject Frida in an application by adding a dependency to Frida Gadget dynamic library. That will call back to your Frida servers and give you the opportunity to instrument the application. But you will be, without using ptrace, you will be limited to data-only modification or interception. Because remember, your iPhone is not jailbroken and no debugger is attached to your process, so you cannot modify its code, only its data. In both cases, you will have to resign the application to modify its entitlement or to add this dependency, which is a problem because it's a tedious process, but it also has a lot of side effects. Because you don't own the original developer's private keys, or well, generally you don't own the original developer private keys, you cannot sign with the exact same provisioning profile that was used to sign the applications. So this means that your resigned application will not have its original team ID, and you won't be able to, for example, communicate with other applications from the same developer or access some secrets in the keychain. This will also modify the files because, well, you resign the file, so it modifies it and it opens a way to detection. So this could be detected or even introduce bugs and crashes in your application, in the application you are trying to study. The good thing is with a jailbreak, all the restrictions are gone. You can attach to any third-party application. You do not have to resign anything. You don't have the only limitation still in place is that you will not be able to debug system applications on iPhones with recent system on chip because of PPL. But this should not be a problem for auditing other applications. Okay, so now that I've introduced the problem, let's talk about a real-world case. The target I'm going to talk about is a banking application. So when launched on a jailbroken device, it immediately crashes with a bad access. Its executable is quite large, 31 megabytes, and it will not be possible to review all its code. When we open it in IDA, we didn't detect anything special. Objective-C methods and classes names were not obfuscated. Strings were in clear text. The code didn't seem to be obfuscated. But given the size of the executable, that doesn't prove anything. Maybe some part of it were indeed obfuscated. We tried a few PRIDA scripts found in the internet that try to bypass jailbreak detection by hooking some functions. So most notably, one written by Space Patrol Delta, an Indian company that wrote a blog post about jailbreak detection in TikTok. But even if a few file manipulation functions were indeed trying to detect jailbreaks and were correctly intercepted by the script, our process always eventually crashed. So we had no choice left but to dig into the assembly to find how our jailbreak was detected. So the good thing is that our crash is a read at an invalid address, whereas the first crash was a read at an invalid address in our main executable. So we can statically see what's the source of the crash. So we can quickly see that this line of code doesn't have any sense and will always crash the process. There is a logic AND between a static address and a very low value. So the result of this logic AND will always be a very low value. So this value will be dereferenced and will always be in the null page. This cannot be a legitimate code, and this is good for us because it means that the address is not a corrupted value that may have been corrupted way before being dereferenced. If we look around in the same function, we can see several suspicious decrypting loops. There also seem to be some integrity check, even if their status is not always checked. Maybe it's a bug in the protection, but well. Finally, there is some synchronization functions to make sure that decryption routines are not executed twice by a racing thread. That's a detail. The really interesting part of this code is that we can see a call to a max syscall that executes the U times syscall. So for those of you that who may not know this syscall, it may be used to change the file access or modification time. So here it's called with an invalid array because it takes an array in the second argument. And the trick is that U times will return a value, will return a different value if the file specified in the first argument exists or not. If the file exists, then it will try to dereference the array passed in the second argument. And it will fail with an invalid access error, so without touching the file access or modification time. But if the file does not exist, it will directly return with an invalid entry error. So this is just a convoluted way to check if a file exists or not. But the really sneaky thing is not that it uses U times. The sneaky thing is that it directly execute a syscall. It doesn't call a function. So if we look at the assembly code, we see that our app directly executes a service call to the kernel with the SVC instruction. It doesn't call an imported function that we could easily intercept with Frida. So that's why the precedent script wasn't working. It's because they use direct syscall. So there are syscalls that are directly executed. So this is not really compliant with the app may only use public APIs policy, but so far it doesn't seem to bother Apple. So the problem is that we cannot just hook exported APIs, and we cannot patch every check by hand because there are more than 400 syscalls in the application. So we need to automate this task. We could eventually patch the blacklisted path used to detect jailbreaks, but strings are encrypted with random values, and there are some integrity checks. So even if we could do that, it would still be a tedious process to figure out the encryption patch values. Moreover, as we will see, there are some checks that are not based on file path, so it wouldn't be sufficient. What we would like to do is to intercept all the syscalls with Frida to manipulate their arguments and return value, just as we do on functions. So for those of you who are not already familiar with Frida, here is how you can hook a function with Frida. So those are our examples from the documentation. So you can define two callbacks, on enter and on leave. And in those callbacks, you can read and modify the arguments, the return value, but also read or write the application memory or its registers. Well, you can do whatever you want. You can also share a state between the two callbacks via the this object. Between the on enter and the on leave callbacks, the original function will be called, and you will be able to intercept it back in the on leave callback. Another method to hook function offered by Frida is to completely replace the implementation, this time with the replace method of the interceptor object. For example, in this example, we replace the open function by our own version that prints debug information. And the neat feature of Frida is that you can still use your original function in your replacement function. Well, the fact that you can quickly code all these hooks in JavaScript without having to compile anything or to deal with some dirty assembly details is really where Frida power lies. For example, if your hook code is buggy, you just get JavaScript stack traces and your injected process stays alive and you don't crash. It's really handy. Not so well-known feature of Frida is that it also allows you to intercept arbitrary instructions. Instead of passing an object with two callbacks, you just pass directly a function, and this function will be called just before executing the original instruction. So it can be very useful to dump decrypted values or key in memories in the middle of a function. The problem is that Frida, although being a great project, is not magic. So to redirect the execution flow, it may need to patch several instructions. And ARM64 instructions are 32-bit long, so obviously you cannot always stick a 64 destination address and an instruction encoding in just one instruction. The problem is that if a branch jumps precisely just after our syscall, after you start intercepting an instruction, it would jump in the middle of our redirection code and may crash our process. Moreover, there is a bug in Frida, and it sometimes trash registers. X16, for example, is used to redirect the execution flow without being saved or restored. When you hook a function, this is fine because x16 is caller saved and is not used to pass arguments on common ABIs. So it's okay to trash it in the beginning of a function, but it's not okay if you're in the middle of a function, because then x16 might be used to carry local variables, for example, or temporary data. So we tried to use this method to intercept all the syscalls, but we didn't. It didn't work. The good thing is that Frida also allows us to intercept exceptions. By exceptions, I mean native exceptions, like invalid access or breakpoint, not C++ exceptions. So with Frida, you can set up an exception handler that is called whenever there is an exception throw, and you can decide to handle this exception yourself or to pass it to the original handler. So our solution is just to replace all the syscalls with breakpoints. This ensures that we only patch one instruction, so we don't have the problem of branches pointing just after our syscall anymore. And we are sure that our breakpoints will throw exceptions that we'll be able to catch in our exception handler. And in our exception handler, we will be able to modify the context of the application to emulate the syscall. So to patch all the syscall, here is the code we wrote. It's very simple. Just the interesting part is that memory.patch code takes care of these methods take care of all the code signature, cache coherency, etc. So again, Frida do all the heavy lifting for you. You just have to give it even have an assembler writer help to help you generate simple assembly payloads. So, well, this tool is great. So after a few tries and crashes, we implemented a lot of syscalls. The methodology was quite simple. We launched the application with our Frida script and wait for a crash. The crash could happen for two reasons: because a new syscall was encountered and we weren't already emulating it, and or we could also crash for if we encountered other anti-jailbreaks methods that detected us. So we found numerous other anti-jailbreak methods based on normal functions, so that wasn't already catched by our syscall hooking method. But for all this detection method, the process always crashed just after the check with an invalid dereferencement, an exit, or a call to a function with invalid pointers. So it was really easy to find the check and to add the countermeasure in our code, in our JavaScript code. The problem is at one point, the process started to crash, but this time with trashed PC and LR registers. So there was no easy way or direct way to find the underlying test because, well, we jumped at an invalid address. This is where Frida, well, again, saved the game, because Frida has a dynamic binary instrumentation engine named called Stalker that can be used to log all the that can be used to instrument all the instructions executed by the process. So it can be used to log all the basic blocks executed. So the idea is very simple. We just run the application until the last successfully bypassed check, and we trace all the basic blocks until we crash. And with this method, we are sure to find where the branch that corrupt our PC register is. The only thing that you have to take care is to make sure to use a synchronized method, because Frida loses the buffered messages when the application crash. So this quickly gave us the culprit of the crash. It was just an API that we weren't hooking yet. Again, just a quick overview of the code. We see that for every basic block, we just add, if the basic block is in our application, we add a callback that says us if that we are executing this basic block. So again, this is really simple to use. The only thing that you have to take care is to instrument the basic blocks directly and not use the high-level APIs that give you all the calls and executed block, because it is an asynchronous API. So to resume, how the application was trying to find out that our phone was jailbroken, it just used very few methods, quite easy to bypass. So they were trying to find jailbreak specific files with open, utimes, stat, passconf, stat64, sorry, and fopen. And they were using both syscodes and exported functions. They also tried to block and detect debuggers with ptrace ptdeny attach, and checked if the parent PID was launchd with get parent PID and check if it was 1. And the little iOS specific method is that they try to detect if the rootfs is writable, because in iOS the rootfs is always read-only. So our solution is based on a generic API, so a generic interface to both functions and syscalls. So you can specify the function name, and if it has a corresponding syscall, you just have to give the syscall number, and in the hook will be used for both the exporting functions and the syscall. We can handle special case. For example, in open, we will have to close the FD that was open before returning to the function. Well, this can be handled quite easily with the onLeave method. We will release the code in the past few days, just it's time to clean it up a little bit and remove all the references that may still be in there to the original application. Future, I have still 1 minute. So what could be used in future anti-jailbreak methods would be to try to load an invalid signature and see if it's accepted. So you can use for that the fcntl function with fadd6 flag. It can be used to ask to the system to check the signature of a file. So of course, if the system accepts an invalid signature, that means that the system is jailbroken. You could also check if some jailbreak libraries are loaded in your process. So for example, the substitute dynamic library. And to do that, you could use dlopen or memory scanning, DLD, internal structure, etc. And you could also check if your process is instrumented, just for example, by checking code integrity or to time the code execution. It's the basic anti-debug check, but you could also try to detect FRIDA with signatures or something like that. Last check that you could use is the CSOps to make sure that your program is, your application is killed if the signature of your process change because of insertion of breakpoints or modifications. And I'm a little bit late, so I'm going to determine to finish now. The last thing that you would want to do is to crash as far as possible of the checks to make sure that it's not easy for a reverse engineer to find out what your checks are. So you should use a global context and put your crash as far as possible to your checks to complicate the backtracing. So that's it. Just a little bit late. Sorry for that. If you have any question.
No problem. Thank you.
Thank you.
Sorry, I will be the only one to close. No,
it's okay. Thank you. So I'm in the chat, but I don't.
There are 2 questions. Yeah.
You see the QA button.
With the first allowed if you want. Does PPL protects only kernel pages or also system user processes?
It does protect user processes, but only system ones. I do have some bonus slides about that. So PPL is used to protect system services. So it forbids to inject any third-party executable. You cannot map any third-party executable in system processes. It could be deployed for all the processes, by the way, but so far, no.
And you have a second question. Xavier asks, it's strange that Apple doesn't implement a simple API call like is debugger present? Is there something like this jailbreak detected?
Well, there is a simple method. Oh, LibreOffice just crashed. Classic LibreOffice thing. Oh, no. Sorry. I'm going to stop the share. How do I stop share? Okay, that's it. There is a simple method. You can use ptrace with ptrace deny attached to both detect and block debuggers. So
the check is quite easy in the end. Okay.
There is, but it's hard to do generic is jailbroken API because, well, jailbreaks try to not be detected. So yeah. I saw that there is a last question. How does the jailbreaks bypass PPL? I don't know how to do it. I don't think that tweaks work on post A12 socks, but I may be wrong. As far as I know, there are no public PPL bypass, whereas there have been a few bypasses, but more theoretic than real life bypasses. But you can sort of work with PPL, for example, by doing data only manipulations and patching only. And by catching exceptions, for example, to manipulate the process without modifying its code pages. I don't know if it's clear.
Okay. And in your talk, do you imply that some developers can access non-public API like syscall? I mean, do they have special licenses or?
I don't think so. I think it's just that Apple doesn't really try to block this, and they don't care if. I think that they don't care.
Yeah.
And
this goes through the qualification process, I guess.
Yes.
Okay, well, thank you again.
Thank you for having me, and thank you for listening to me.
Okay, I see our next speaker is in the attendees. Maybe we can promote.
So, thank you very much. We'll put again a countdown, I hope, without music this time, so to lessen the risk of crash from my side.
Okay.
Do you hear me?
Yes.
Okay, so maybe you can start sharing your screen so that we can confirm that everything is okay. All right. It's working perfectly. So our next talk will be by U039B, which is, if I'm not mistaken, the code for the Lambda letter. So this talk will be, she's an independent IT security specialist, and we'll talk about Pitus, which is a tool that will let you analyze Android apps. The mic is yours. I guess we're not hearing you right now. Sorry, we can't hear you. Or maybe it's yeah, it's too low maybe.
And now?
Yes.
It's better.
Yeah, no clipping. It's okay.
Can you have it a little more, a little louder? It's
And
still
now?
very low. Okay, I think that's right now.
Okay, I hope that Zoom is not messing things around. So is the level totally okay now? Should I start or should I?
It's quite low.
Yeah,
Okay.
it's still quite
So,
low.
And now?
It saturates.
Okay, awesome.
Try again.
Okay, and what about now?
Yeah.
Oh, good enough, I guess.
Okay. Okay, yeah.
Okay. So, hello everybody. Thank you for having me over here. So today I will talk about a project which is named Pitus. I co-founded a few months ago. And Pitus is meant to be something open to analyze Android apps. So first of all, a few words about me. So I am Esther Amfra. I am an expert in Android security and reverse engineering, and I'm a French activist and speaker. I am co-founder at Defensive Lab Agency, which is a small company specialized in cyber security. I am also co-founder at Exodus Privacy, which is a well-known French not-profit, which is meant to bring more transparency in the tracking ecosystem on Android. I am also co-founder of ESHAP, which is also a French non-profit which fights against violence against women using technology. I'm co-founder of Petus, the project I will speak about today, and also co-founder of Peer Analysis, which is the equivalent of Petus, but in terms of dynamic analysis. So, what I do all the days. So basically, I do penetration testing on mobile devices, both on Android and iOS. I do regulatory compliance audits for customers, so private companies. I also do a lot of reverse engineering of both malware and SDK. I put them on the same line because usually SDK use the same techniques as malware to hide their behavior. I'm also expert witness in different class actions, at least in the US. When I have time, I craft open source and free software. Sometimes I give talks in Froglish, like this one today. And during the weekend, I do trainings and awareness conferences also. So basically, I work for lawyers, DPO, CISO, NGOs, academics, journalists, etc., etc. So maybe you have seen me on your TV or on your more smaller screen in cache investigation. So now I will try to explain why Peters and what is Peters. So first of all, why? So the candid reason is there is a lack of open source threat intelligence tools in the Android world. But the political reason is that for me, threat intelligence and threat analysis should not be the proprietary of a private company. And at the right side of the slide, I just put few screenshots of the pricing of VirusTotal, but, because VirusTotal is a well-known threat intelligence platform run by Google. So yeah, it's the first part of the why, and the second part of the why is this one, and it was a quite long story, but for short, back into 2020, privacy activist I worked with asked Avast for an increased quotas on APK Lab because we were conducting an investigation on a mid-scale scam campaign in India, and Avast said they want more recognition in the privacy community after the scandal they had last year. So yeah, they refused to give us access, and yeah, the scandal was that leaked documents exposed the secretive market run by Avast. So basically, the company was selling what are your searches, what is the link you click on, what you buy, etc., etc., to different customers like Home Depot, Google, Microsoft, Pepsi, Bookstore, etc. So yeah, and maybe you know that the Avast antivirus for Android is basically just um, a large hover collecting a huge amount of personal information and browsing history, etc., etc. So yeah, so basically Avast doesn't like privacy activists. So I decided with other people over here to start building an open source threat intelligence for Android apps. And here is what is Pitus. So Pitus is basically an open source mobile threat intelligence, but moreover is also a playground because since it's open source, it's a good opportunity for us to invent new way to analyze the samples, to colorate them, to determine if there are clusters into the the database, extra, extra. So the platform is entirely driven by its community. So it's totally free to use. So you can easily submit a sample, and you can also conduct advanced searches over here. It is only based on existing free and open source software tools like MobSF, APK-ID, etc., etc. And it's self-hostable, so you can easily host the entire platform on your laptop or in your company, etc., etc. But Pitus is not meant to be a commercial product. And so if you want to check it out, you can just go browse the web at beta.pitus.org and just try it. So few features over here. So with MobSF, we are able to extract all the domains and URL defined in a given APK, and we compute a word map highlighting where are located the servers corresponding to the different domains. Since we also grab the information from VirusTotal, we are able to compute the sample timeline. So it's sometimes useful when you are studying mid-range or large-range malware campaign. There was also a bunch of tools like MobSF, but also Quark Engine to statically determine what's the behavior of the application. You have also, here is an example of the different data we retrieve from the APK. So here is the certificate details. So the certificate that has been used to sign the application. And you can pivot on each indicators, even on the MD5 of the certificate or on a domain, etc., etc. And each time you pivot, you will have a list of all the applications having the same attribute. And here we have the different data retrieved from Malware Bazaar. So here are the basic features. And moreover, for the threat intelligence part, we use DexoFuzzy for computing fuzzy hash of each sample. So after that, we are able to compare them quickly in terms of similarity in the code. They are sharing code, etc. You can also run retro hunt. So basically, you upload your rule set on Pitus, and you launch a retro hunt, and you have the list of the samples matching your rules and the files containing inside the APK matching your rules, etc., etc. You can upload your rules and turn them private, so you are the only one to see the results or share the results with the others. And few weeks ago, we were working on some kind of genetic analysis on the sample, which is based on the control flow graph analysis. So here is a screenshot of the result you will have. So basically you do a search, and at the top of the results you will have some kind of a tree representing the similarities in terms of control flow graphs of the samples, and the x-axis represent the percentage of difference in terms of control flow graph topology. So now let's talk a bit more about CFG and how we dissect them. So quick note about CFG. So what I call here control flow graph is a graph in which each node represents a method and each links represent a call between two methods. So we extract the CFG from an APK. So you can use undergrad for that. So first of all, you analyze the APK. So you give it the path to your APK, and then you can retrieve the call graph of your APK. And you have the entire call graph of your sample here, which is some kind of a bunch of pasta. And another interesting feature of undergrad is the ability to locate both a method and a class. And here we are looking at the getDeviceID method, which is defined in the telephony manager of Android. And this method is meant to return the IMEI of the device. And with undergrad, with this simple call, you're able to return all the methods matching the two regexes here. But here we have a perfect match, so the array here will contain only one method if the method is called in the application. And to do more interesting things with the two primitives we have seen before is to construct the control flow graph of a given Android API. So here I'm still focusing on the getDeviceID API exposed by the telephony manager. And in my sample, I want to retrieve all the different pieces of code or the different methods directly or indirectly calling the getDeviceID API. And when I construct the CFG of a given API, I have one leaf, which is the API, and multiple routes at the graph. And the multiple routes are probably entry points in the application. And if they are entry points, that indicates that the code is presumably called. So here we have two tasks defined in the sample, doing something in background and then execute after, which are indirectly calling the getDeviceID API. Here is just an intermediate node, which is the aggregation of the different nodes between the entry points here and the API here. So when you look at a report on Petus, you will see two different things. The CFG for different Android API we are tracking. So here is for the retrieve of the IMEI. And you will also have a screenshot of the code calling directly this API. So you can click on the piece of the code, and you see the entire code of a method calling this API. And then what if we are able, or we try to compare two CFG? So what we have implemented in PITIS is really basic, and it's the most basic things that has been described in the academic literature. So for each sample, we compute the CFG, and we count the number of entry points per type. So basically, an entry point could be an activity or a thread or a task or a listener, for example, on intent, etc., etc. And for each API. And in PITIS, we track 100 API and 13 different entry point types. And then you flatten it into a vector of n dimensions. And since you have here, as an example, the API one has 12 entry points of this type in the CFG of the sample, we are able to compute pairwise distances, either Euclidean or the Jaccard distance. Then we normalize the distance. So we don't want a distance, but a percentage of difference. So with some kind of magical cross multiplications, we achieve the normalization. And then we compute the hierarchical clustering, which is a statistical method, which is really simple. And then we represent this clustering on a dendrogram. And a dendrogram is also referred as a phylogenetic tree. And so here we have the result that is displayed on PITIS. We have the dendrogram for a list of sample, basically the results of a search. And what you see here on the x-axis is the percentage of difference. So here we have at least 3 samples here, which are really similar in terms of control flow graph. Here we have 2 samples which are really similar, but nothing really similar to them has been found, because we see here that the line here indicates the difference between this subgroup of samples and this one. So here we have several samples with a very low percentage of difference. So maybe we could find a cluster here. So maybe some kind of variant of a same malware, or counterfeit version of an official application, etc., etc. And here we have a single sample that is totally different from all the others. And why we decided to look at the control flow graphs is because we wanted to have a way to easily compare 2 samples in terms of behavior. And we make the choice to focus on 100 different Android APIs, like get IMEI, but also retrieve the contacts, or read the call log, read the browser history, etc., etc. And so we want to have some kind of DexoFuzzy-like way to compare applications, but in terms of behavior. So what we know, at least, that is when DexoFuzzy find a large percentage of similarity between two samples, a way to compare the samples with the CFG comparison achieve the same results, but we also were able to find some kind of variance in FinSpy. So now a small conclusion. So keep in mind that Petus is still in beta and we are only 3 active contributors. The first success we had is we have detected a few months ago FinSpy hidden in the latest version of Wire. Unfortunately, even if we have contacted Wire to get more information about that, no answer were received. And the C2 of this sample was operated by, I don't remember, Etzner, located in Germany. And we contacted them, but no answer for them. So we need help, we need things, maybe from you. We need feedbacks, we need contributions, and also some kind of liquid brain juice and more tests. Yes, definitely more. And feel free to contribute to test, to send us feedbacks, or if you find issues, and we already know that we have a large bunch of issues, just feel free to report them or to try to fix them. And if you want to play with the data already computed by Petus, feel free to experiment with the data, maybe implement new way to dissect samples, etc., etc. One additional note over here is that if you connect your GitHub account to Petus, you will be able to retrieve the report in the JSON format. And in the JSON representation of the format, you will have access to even more information that those are already displayed on the report. As an example, you will have all the secrets defined in a given APK. And then after, you will be able to pivot on, for example, Firebase, API key, etc., etc. So this talk was meant to be short in order to have room to discuss, to have questions, etc., etc. So thank you very much, and it's up to you now.
Okay, thank you.
Thank you.
Well, sadly we don't have any question right now, but I will
Awesome.
try to come with one. So with Eloi before, we just had a talk about the detection of debugging and things like that. Do you run into many samples that block the analysis that you do with the tools, or is it so frequent?
Yeah, so Petus only does static analysis. But from my own experience, a lot of applications and also SDK detect the application is running into a virtual machine or in an Android emulator or on a jailbroken device, and refuse to start, or just start but with a limited with limited features. When you, as an example, all the SDKs for data monetization detect that you are running on a sandbox, and they simply die. So you cannot observe their behavior using virtual machines or AVD. So you have to run them into a real device and use readout to intercept different calls, and use, as an example, MITM proxy to determine what are the different data that is collected, etc. But in PETUS, you have in the fingerprint tab, you have the part generated by APK ID, and you see if anti-emulation means are used or defined or not in the application.
Okay. And have you run into well, there are also protections against the reconstruction of CFG and things like that. Is it frequent in the samples that you have observed?
Well, it depends. As far as I know, with SphinSpy, it's really easy to reconstruct the CFG. With Facebook with its own SDK use reflection, and basically reflection totally broke the CFG, and by using underguard, we can simply reconstruct CFG when it was wanted to break the CFG using different threads. So basically you have one thread creating a new one, and since you have a thread switch, you cannot easily reconstruct the entire call graph. But if you're able to, so you start with the API, you take all the ancestors of this API, you arrive at a root in your CFG, and if this root is of type thread, so now you can start another search to constructing another CFG with the leaf of the CFG is the call to the init of the thread. And so you can go back to the node that has created the thread and then reconstruct a new control flow graph and identify new entry points, etc., etc. So you can easily track back thread creations. You cannot track back the call to the run method defined in a thread because in Java, run is directly called by the JVM. And you cannot also efficiently track back the call to the start method, because in Android, applications usually use a thread pool, and it's the thread pool run by the JVM that will call the start methods. So the most efficient way to reconstruct some kind of call graphs when it has been broken using threads is to track back the init methods. I don't know if it answers your question, but
Okay, yeah, I guess there are many different techniques to break the CFG, so some can be addressed, and maybe others can only be addressed with some kind of execution engine. And
yeah.
so, right now you only have so symbolic or so well the binary analysis and not the execution engine right
Yeah.
now. That's it.
Yeah, but for the dynamic analysis, it's in another project, which is pure analysis. So quickly, pure analysis is a tool suite around a single device, which is a pirog. which is based on the Raspberry Pi. And the objective is to automate both the installation of the root certificates for SSL interception, automate the instrumentation of the application using Frida, Dexcalibur, etc., etc. So in an ideal world, in the future, I hope I will be able to cross the line between what we have found by static analysis, what we have found in dynamic analysis, and correlate them. So, but yeah, you know, there is only 24 hours a day, so that's a problem.
Yeah, I guess referencing the results from various tools can be quite the task. That's true. Yeah.
Mm. No questions in the Q&A tab?
No question.
Great. I was very clear.
Sorry, sometimes. Well, it's always more delicate in an online setting like this.
Yeah, no problem, no problem.
Without the audience face to face. So well, I guess we will thank you once again.
Thank you very much.
And we will have the 5-minute timer for the next talk.
Okay, bye.
Bye.
Thank you again. Bye.
Hi.
Yes, hello. We can hear you.
Okay, cool.
So we'll just wait 4 minutes to be on the schedule, and then you will then be able to share your screen.
Okay.
Okay, Benoit, maybe you can start the screen share. Okay. Well, we have a small residual black bar from Zoom, but well, I guess this will be okay. It's always difficult to get rid of this.
I don't know how we can do that.
As long as you let it reduce itself, I guess it will not be a problem.
But no, I don't know.
Okay, so next talk will be by Benoit Forget from Digital Security, which used to be one of our sponsors. And he will talk about hooking several kinds of devices. So the mic is yours.
Okay. So hello everyone. I would like to present to you a new tool I developed to give back the power of an analyst doing an analysis of Android mobile application. So who I am, first of all, let me introduce myself. My name is Benoit Forget. I'm currently working at Digital Security as IT security engineer. And I work on the security of IoT device, and I assist during a project a client to implement security feature on their device with a getting accurate label delivered by Digital Security. So during this presentation, I will explain why I choose to be interested on the Android system. Then we will focus on the existing tools. After I will present what is Astook, and next we will continue with an execution routine of the tool to understand the internal mechanism of Astook. Finally, I will present what the tools will become. So why Android? If we look at this graphic, we can see that Android becomes the most important operating system with 88% of the smartphone markets at the end of 2018. Moreover, during my experience, I met more and more devices using Android system as a head unit of automotive, or for instance, I see a device using a Quectel SOC, where the SDK provided by Quectel is a custom Android system, and we can push it to make our system and interact with the hardware of the device. So why Android rules the world for me? The recent probability of Android become from 5 points, I think. A bootloader provided by the SOC with an easy configuration to secure it. As I said before, Quectel give an Android system with all configuration already done, so it's easy to have a secure bootloader. An API for hardware as a radio functionality, NFC, BLE, etc. Moreover, the containerization is by design. So we have a system was containerized with ARM Trojan, but not on each device, but some device. And all the application is also containerized. Moreover, we use a high-level language as Java, so it's easy to program it. And we can interact with another application, so other process with services, activity, provider, broadcast. So to have a better understanding of the mechanism of Android, we can look this graphic. each application is sandboxed inside the .big there, and all files is restricted by Unix write functionality of Linux and Android permission. More generally, all access are restricted by permission and asked during the installation or when it's needed. So for instance, you have a pop-up on your Android to ask to add a new permission. So we can see here Android permission. With permission, an application can have access to GPIO, SPI, SMS, BLE functionality, like here. And if it's needed to communicate with another application, we use a kernel module, /dev/binder, to access the service activity broadcast provider. And all this action can be protected by the permission enforcement. So we have some feature on the application. It's the activity. The activity is just a splash screen you have when you launch the application, and you can have some other splash screen to a different menu. The service is the same thing, but it's like on background, just when during the application is running, and just make some things just in background. We have a receiver, so it's, for instance, when you receive an SMS, you can register to the receiver of SMS and receive the content of SMS, for instance, for the 2FA authentication. And you have a provider. It's like a database accessible for the application to have some feature and request what are the application. So I'm interested to the existing tools before I create a new tool. And I didn't find a tool to do what I exactly want. I see interesting feature as IST analysis or generation of APK to exploit vulnerability based on analysis, perform SQL injection on broadcast, not on broadcast, on provider, and make a dynamic analysis, dynamic hooking with Frida. But it's not really I want. So I create Astuk. So what is Astuk? I will use the modular plugin, the analysis, the tent analysis. I will explain what is tent analysis just after. The POC generation. We can use emulator on a physical device or on emulator, and can be used on alone with root or not root phone, because sometimes we need to use not root phone, and sometimes we haven't a root device, so we need to adapt. And what I want to add it with this tool, it's use the dynamic and static analysis result to have a better result. So when more you run the tools, more you have a result. And the second thing is the instrumentation of the form. You can launch the tools and use with another tools to manipulate the application. And it's not just a black box when you give an application to analyze. So story time. What is Astuk? Astuk comes from the AST, generated from Java decompile code. And an AST is a tree where all edges are the operator and all leaves are the operand. So for instance, you have 2 multiplied by 7 added to 3, and you can have all the operand on the left, so on the down, and you have the operator, so we can read just here 2 multiplied by 7 added to 3. Just to understand what is AST, but on Java, it's more like we have a class and the field and etc. And I will show just after. And hook. So hook, it's a programming paradigm which can upgrade or modify a function. So, for example, all nodes of the ISA have a visitor function that we can hook to analyze the code. And when the application is running, we use Frida, a popular tool to make a dynamic analysis on multiple platforms. We can have on Windows, on Android, on Linux, on all devices, all architecture you want. Hastoop use it to hook a function of an application and monitor or modify its behavior. And so what Hastoop analyze? So we can monitor the user input in static analysis and receiver and service execution provider we called before. And all permission and communication between another application. And for the moment, you can also have the BLU feature, and you can have an emulator access on the file system used by the application. So you have the same ID than the application has. So you can not access to all the file system. So, oops. So we'll see at the beginning as to will decompile the application with one of these decompiler to produce from the APK the Java code. So we have a CFR, Proxycorn, JDCore, and Panflower. You can use it and compare the more performance. And then we will structure the project. During the first step, Hastoop will create a directory with the application and decompile name, where we can find a file, info.json, with some information about current decompiler, the date of last decompilation, the date of the last patch, and the architecture of the patch. And so I will talk about the patch after. And directory with previous decompilation. With so for instance JADX and CFR, and directory with POC. It's a functionality where we can generate POC to export some vulnerability. So when the tool is launched without option, only a quick analysis of the manifest is execute, where it's a list dangerous functionality used, interesting permission as write access, to indicate to monitor user input, the activity, service, broadcast, and provider exported. Exported, that means another application can use it. Because if it's not exported, another application cannot use it. It's not possible. So then we analyze the source code. So when we had the option tree, the AST of the decompile call is built, and all hook configure is called during the tree, during the browsing of the tree. And so I see, like I see before, we have the class declaration, login activity, and all field declaration, method declaration, and in method declaration, all the function of the method declaration. So it's more easy for a program to read an IST than just a code, a raw code. And when I say before, the functionality is hook. So we can say a type of node, so local variable declaration. And in entrance, we call each call of local variable declaration, we will do these things. So for instance, here it's to monitor the user input. So user input is basically when we have an edit text type or a text view type. So we just hook the local variable declaration, and we check the type of the variable, so edit text or text view, and just add it to the output of Hastoop. So now if we look at more complex plugin, we have the tint analysis, what I say before, to have a better analysis of analysis. I developed the tint plugin, which spread the tint of all variables defined uniformly and defined by the scope of analysis. So what is the tint? Tint is useful to follow a variable on each use of it inside the Java code and mark it the probability of using one variable at this location inside the Java code. And this tint analysis is made at object level. So to create a tint, we just look the lifespan of the variable. So it's defined by the scope of the variable. And what is the scope? The scope is defined. It's the for the people know compiler is the binding moment when we define a scope where each variable is defined inside and will be destroyed when the scope ends. So for instance, a body function, when we have a variable in the body function, after the end of the function, the variable didn't exist anymore. So we have a body of function, the parameter of for loop, the body of class and body of namespace, etc. A lot of scope like that. And so for instance, we create a scope with the class A. So we have a variable defined here. We have a class A, a value here, which we define hello. So when we enter in the class, we define a variable with a name hello, and then we create a new scope because we enter in function hello, and we print E, B, and C. B and C is defined on the parameter function. So we create a scope in the hello, and then we call also E variable is defined in a class. So it's in B for scope, so we can call it. And just we create a scope like that and destroy it and to make things like that. And a quick example of just before. So we need also a binding of a variable. So to bind a variable, what it means? It means when we have a function, for instance, main, we have a class A with the function hello, and we put the parameter A, and A is called the function hello of the class A, and so the parameter B is linked to the variable A, and R is linked to a variable C. And to see a more complex plugin, complex example, we have this code was produced, and then Asuk can produce a tree with all links of the variable to see the binding of the variable. To see a quick example of using this plugin on an other plugin, we have a function. We have a plugin to list a call function, and with a pattern matching. So we just make a regex to found the call function, and we can see a better result when this plugin tint is called. So for instance, we have here all the function call found, and then we can see the class was of the object used is easily found. Another plugin I think it's interesting. It's the generation of APK. So Asuk can generate some APK with a Jinja template and create a folder to remake the application. So we analyze, for instance, we found some results when we analyzed the source code with AST, and we found some fields like the application, like activity, classic, and some data, and we can just generate a custom application to exploit a specific application. So we can have this instance where we can just to call on the code to make an exploit. So I just show this example. Oops. So just we launch the application to create to create an exploit. We have where the vulnerability is found. So we go to the code in line 24 and column 29, and we can see as to identify in the code. We can inject the data validate, and when it's false, when it's true, the text show is good job, and if it's not, nothing happens. So when we can launch Astuk to launch the application. No, just before. So we have the oops, just a moment. So we have the folder I speak about before. We have all the files and to make the application, and we launch the application. So the application will launch, and oops, sorry. When you enter the wrong password, so you see you are not allowed to be here. But if you enter a password, you have good job. So if we want to exploit this, we just need to now install the APK was created by Astuk. So we have an APK, and when we launch, we have good job. That's it. So how the APK is made? We have the Java file produced by Jinja, and then we compile it with in .class file, so the Java classic Java compilation. Then we produce a Dalvik executable, so DX, a DEX file, and then we package with Android.jar to produce a real APK with Android manifest to have the activity exported and all like this we talked about before. And then we need to sign the application. So the application was signed with auto-generate certificate, because not with Apple, where we need to have a real certificate. And then we just zip a line to have a valid application APK, and that's it to run a new APK. So we have a make file, we produce all like that, and just we need to remake or modify the code to make another application. So it's really easy. Finally, we will talk about the dynamic analysis and instrumentation provided by Astuk. So when we pen test an application, we often need to intercept the HTTPS traffic, and so we need a proxy. And the setup of proxy server was fastidious before, but not anymore with Astuk. We just need to download the proxy certificate, pass it as argument of Astuk, and wait for interception. So how it works, so you need just to have the certificate in CER format and then transform it in STEM format. Rename it with SHA 2016, and then upload it to /system/etc/security/cert. But this partition was on only on read-only normally, so we need to remount. But when we to remount the partition, we need to be root. So and what if the fund is not root? So to just a quick reminder. We have the Android manifest where activity service provider permission is defined. Then we have an asset, a directory for raw file, HTTP or web page for Cordova application. Then we have the class.dex, so it's the Dalvik executable which contains the main code, and after the lib, where we have a subfolder for each architecture, like this, and meta-inf, where we have the same signature, and finally res, which contains the compile by the application toolchain, and we can retrieve drawable for description of a UI, and raw folder, which contains, for instance, X509 certificate, so for the proxy certificate, and an XML subfolder with in generally configuration file to explain how the application will work. And I developed a tool that can be used as standalone application patcher. This tool can inject a library and certificate directly inside the application. So we have so extract the application without resource, because if you extract with resource, you should have some problem because the res folder is not really correct. And extract Smiley code. So Smiley code is inside the Dex executable. The meaning to talk is the language. So we just modify the code to inject a Frida binary. So the code to call the library. And also we download the library to inject directly inside the APK on the lib folder. After that, we need also to modify the Android manifest to inject internet permission, because it's not really an internet permission. It's just like a socket permission to communicate between the PC over a Unix socket. And we inject also a network security config, Android binary and Android binary XML, and add a certificate user to package the APK. And we see before how to package exactly an APK. Just upload the new APK. Now we have so the plugin interface. We can use ADB. So we have a wrapper to have a shell, push, pull, and install and spawn function, and we can modify to have a more esoteric architecture. So, for instance, if you are on a head unit of automotive, perhaps you don't have exactly this command, so you can modify to still works. And we have also Frida to load and unload script. And so I just show before a dynamic demo. So here I just use burp for the proxy, and we run a Stuck. So we have a configuration file where I set up the proxy, the certificate of a proxy, and the SSL pinning and anti-root enable to have no issue on the application. So we just run a runkeeper application. An emulator starts automatically. So you don't, I don't show, but you have also an emulator name to launch the emulator, but you can use on a physical device too. So it just install the runkeeper and launch it. And automatically have a big database I regularly update to have to bypass the setting, and we get all the requests. And if we log in, so I just log in here. Oops. So log in, and we can have the request just issue down, and we have the username and the password I entered. So we have intercepted the HTTPS request. Then we can also use a shell access, what I said before, with the ID of the application. So we can just list files, but you can also so put the ID, and you see we have an ID U0_A79. It's the ID used by the application, and you can also display a file, for instance, call shellcat, and the file you want to display. You can also have a native hook. So it's just a 3-line snippet, but you can call another snippet, and we can look all hooks of open. Then another interesting thing is you can use a not root phone. So for instance, I use a phone_edit_play store. So you have a Play Store and you don't have a root phone, and you can launch it. And if we look, we patch the application. So I already use it. So the application was already patched, and just reuse an application patch. And so install it and launch root beer to see the application was not root, but we can return also the root functionality using by the application. And what is next? Now I'm only the only developer on this project, and I think for a better progression and its contributors, if the project seduces you, currently I work on the web version to have a server with multiple emulator and use and analyze APK directly on the web interface and interact with emulator directly via a browser with a gRPC server. I can show a quick demo, but it's not really really ready to. So you should see we have the application. So it's already analyzed application, and you have a quick summary of application. But and you can also analyze an application and just run Astrook on background. You just need to have a server. So thank you. You can find the project on GitLab or on GitHub in the 2 following URL. And thank you for your attention.
Thank you for your talk, Benoit.
Thank you.
Okay, so well, sadly we don't have any open question right now. Maybe can you tell us what is the typical usage of Astrook? You use it to analyze the traffic from a particular application, or you use it to monitor IoT devices that go through an APK?
So yes, I analyze for the IoT device, but not only. The last example, we have so an application on Quick10, and we extract the application and just analyze it to understand the BLE feature and see how the encryption is done dynamically, and have a static analysis of the application. But we use also for the more classic application, because when in my company we receive a lot of application, and to avoid to bypass the SSL pinning and anti-root and instrumentation, it's better to use Astuk and just run and have the result to analyze.
Okay. And well, our previous talk was about an automated analysis platform, but it was more static analysis. But maybe it could be interesting to connect your web interface project. So it seems like there are some automatization functions in your
exactly
project. So
yes, and I really would like to have an emulator and just use the web interface to interact with the application, so slide and enter some things and all like that, and just have a functionality to monitor and found some vulnerability automatically. It was really awesome.
Yeah, I guess it can be interesting to maybe like also automate some input, user input or user gesture. That can also be interesting to go to some parts of the code and things like that.
Exactly.
Okay, well, thank you again.
Thank you.
And we will have a longer pause right now. So I guess Philip will show the timer, and we will be back at 4:10 for the next talk.
Thank you. Bye.
Thank you again.
Thank you.
So yeah, it will be 10-minute and some pause, and we will see you back right after this.
Okay, we'll continue with Nicolas Mathioko, who will present us a new risk-based vulnerability management tool called Patrol Hears, open source, of course. Nicolas is information security expert currently working as a red teamer and in automating security operation at a large scale with Patrol solutions.
Hello, everybody.
It's yours. Thank you.
Thank you. Thank you for the introduction and for inviting me at this session. Thank you very much. I will share my screen. So, do you see something?
Yes.
Yes.
Okay.
Nice. I will try to. Activate the full screen. And it's started. So hello everybody. I will talk about vulnerabilities and how we manage them in my current assessment. I don't have any answer to any question about how to manage vulnerabilities, but I'm only here to share about my experiences and why we built a tool to help us to make a better decision and quicker decision to prioritize how which vulnerabilities we have to deal with first. So my introduction has been done. Just consider me as a penetration tester, which is recycled into DevOps and manager today. I'm an open source contributor, so mostly on Patrol. I assume that a lot because it takes a lot of time to contribute efficiently with all the communities. So Patrol is my only only contribution. Just a quick overview of Patrol. Patrol is now a company. We are a small startup. Which is based in France, and we have soon we are accelerated by Exatrust. It's new for us, and it's very nice. Thank you for them to help us to help us to manage how to sell product. And we have a new logo. That's all. So just I propose you to go deeper into the topic. The main topic of today is how to manage vulnerabilities. So first, I will start with dirty words for some technical guys. What is vulnerability management? My promise is to talk about it on one slide only. It's about recurring activities. The first one is about how to know the perimeter. So you have to deal with your assets. You have to know your assets. You have to make a risk analysis on this, just to identify which are the critical one and which are the less critical other. To know about their exposure and to manage. Try to manage every technologies you have to deal with within your information system. You also have another big part of the vulnerability management program, which is the watch, the security monitoring. You have to have information about the new vulnerabilities, new exploits, new attacks, which are every day occurring in our company or in concurrent in advisory, and to know about attackers. We talk about the TTP here. We also need to make active control, which we perform a vulnerability scan, we perform intrusion test. Many companies are introducing a bug bounty program. We also have activities like threat hunting, configuration management, source code auditing, and so on. And the last one is about reporting. Just to be sure, the process we have set in the company is sufficient, is relevant, and is enhancing year after year. You always perform the same activities, which is you have to identify vulnerabilities, you have to prioritize them, because you can't manage every vulnerability you identify in your information system. So you have to prioritize them. The happy few which has been selected, you can remediate them, and you have to check the fix is efficient. And this is recurring activities. This is a no-end job. So the first thing, the first thing we do automation, because we have to face the reality. We have a lot of assets. We have a lot of technology to manage. It changes every day, every hour. We have to deal with critical vulnerabilities the quickest as possible. And to do this, we have to perform the previous the activities I've told the slide before. So this is a lot of activities, a lot of time-consuming activities. If you want to know about the vulnerabilities, you have to deal with multiple feeds of data. This data does not have the same quality, and you have to refresh them every time you need it. You won't have any people to deal with all the vulnerabilities, and you have to manage with the budget. So automation helps a lot. Automation gives you the opportunity to perform more checks, so to cover larger and diversified scope. To do it more often, the idea is to continuously check for vulnerability and suspicious changes. The idea is to identify the vulnerability as soon as possible in order to fix them, to fix it as soon as possible too. The next one is to do it more efficiently. The idea of this part is to say, okay, vulnerability management. It's a lot of low value adding tasks. We have to perform quick actions, and we have to make it every day. It's not fun. It's not fun at all. So if you want to remain the team, the expert team motivated, you have to automate them, just to focus the brain on fancy subjects. And the last one is to help about compliance and do benchmark about how good you are and how good you could be regarding other people, other information, other organization. Even though, if you do more control, if you make it more often, so mathematically you will have more findings, and we talk the more findings to manage. So you will have more alert, more vulnerability to deal. It's no like a Christmas tree. If you want to manage them every day, you have a lot of data to perform, and depending the feeds of where you collect the data, it could be considered as critical or less critical or so on, and you have to manage all these indicators, all these metrics in a unified way. So The question here is to efficiently manage the vulnerabilities. The first thing is about triage and prioritization. For this, just to illustrate the idea and why we build Patrol, I will share my morning routine in my client. Every morning we talk about new vulnerabilities that have been discovered. The first thing we do, we talk it. There is a multiple sources of data of vulnerability that come from. We have data. New vulnerability come from the vulnerability scan, the vulnerability watch, the CTI team, alerts coming from IT users and so on. And every morning we take the time to select the most critical, and we talk about metrics. The first thing is we talk about the CVSS DAS score. So depending of the score, we stop here and we consider it like a critical one, and we decide to make a crisis or not, or special communication to the asset owner. we have the question. So, are we vulnerable to this vulnerability? Are we exposed from the internet? Because if we are exposed from the internet in this vulnerability, it have to be urgently managed. Is the vulnerability has been identified on critical assets? The next one is very important. So, are we aware of any functional exploits? We have to manage a lot of vulnerabilities, but most of them are firstly not theoretical, but we don't have a way to exploit them. So we know we have a vulnerability, but no one knows. It's no one, but the public explanation is not available. So it's not the first thing we have to fix. Is there any patch or compensation measure available? And are there any likelihood catalyst? We pose the question. So is it exploited in the wild? Do we have the answer? What is the media hype level? If do we talk about this in public media and so on? Do we have the information about the exploitation of this vulnerability has been exploited by a relevance threat actor regarding our activity? And we pose the question, so are we already pwned? It's not very easy to answer quickly at this after this question, but we also try to identify if we have the ability to detect if we are already pwned. And regarding all these metrics, we have to take decision. So do we have enough data to initiate a crisis and to fix it as quick as possible within the day, or just we have to wait and insert it into the standard, the classic vulnerability management. So if we want to prioritize the findings, the data we are collecting, there is two main ideas. The first one is it's a teamwork, because no one it requires a lot of technical skills and technical abilities to answer all the metrics. It's very rare. We can answer all the questions we pose, because it's not centralized into the central DB, and just to know yes, no, we have to go there. It's involved other IT and business team. They're definitely. The next one is the vulnerability metadata are not static. Definitely not. The answer we have to at this moment, it could be changed, updated the next few minutes, and it's in just if a new exploit is released, maybe it's time to consider it with urgency, and it will change the way we have to deal with this vulnerability. Just a quick focus on the CVSS. As I said before, the CVSS bus score was the first deterministic item. The first metric we try to understand and to deal with. The question is the CVSS bus score is sufficiently enough to be the primary factor of discrimination? A quick reminder of the CVSS score is a score from 0 to 10. 10 is the highest criticality of the vulnerability. We have three metrics. The first one is the base score, which represents the intrinsic characteristic of the vulnerability. And it's very basic. What is the impact? What is the generic likelihood of this vulnerability? What are the prerequisites to identify, to exploit the vulnerability? The next one is temporal. It represents the characteristic of the vulnerability that change over time. And it's like, is there any exploit? And is there any patch available around this vulnerability? And the next one is environmental. It depends of the client, the user environment. Because the vulnerability which is available from internet on a medium critical asset is not the same about vulnerability with a high CVSS score, but only reachable from an administrative or restricted network. We have lots of variation. Globally, is the standard is largely adopted by the user, the vendors, and it's as simple as a number to know if it's hard or if it's critical or not. So it's very helpful, but it could be better, and it have to be better understood to make this score a real asset and a real metric to determine if you have to prioritize the vulnerability or to demote the priority. So obviously, we talked about the best score. We only selected the best score to make a decision if we have to manage this vulnerability first or not. And definitely is not a good idea. Because if we want to, it's quite easy to say that. Huh? So if you want to make the better decision, you have to have the better data, and better data is about all these three terms. It's about how the vulnerability, the asset, and the threats. It's basically done with the three vector, the three metrics given by the CVSS. And we updated, so no, not updated. We have inspired our score system using this repetition of metrics. The first one is about the vulnerability. So we take the CVSS v2 impact and exposure metrics. We try to answer the question: are the patch available? We also deal with the edge of the vulnerability, because if if it's an old vulnerability, it have a higher likelihood to be identified and exploited within the by the attacker, because they have more time to have and to stabilize their exploit. We also try to identify the discovery is and the detection is. Basically, is done by the best CVC score. The next one is about the threat. Is there any exploit available? Is there any known, which is public or private? If you have to pay to have this exploit, well as the exploit maturity, because we can share exploits, but they don't have the same level of maturity. Basically, sometimes we just have the line, the line in the source code which is vulnerable, and you only have the diff between the vulnerability part and the fixed one. And the other time you have a script which is very easy to use. You only set your IP, you click, and you are on. So this is not the same level of maturity, and we have to manage the source of this exploit, because a lot of fake exploits are circulating within the internet, and we have to check about how good or real they are. We talk about the exploit is the threat intensity. Is it exploit in the wild? Do we talk about this in the news, in the mainstream news? So, but not in some private forum. And if you comply with the MITRE ATT&CK framework, it could be helpful to know if this vulnerability has been exploited by relevant threat actors. The next one, and basically, is the most interesting one, and because it's very depending of the assets of the information system you have to manage the vulnerability. We talked about the criticality of the assets, the exposure, because very important to know if this vulnerability is only exploited from the internet or to the restricted network, and what about the distribution. Regarding all these metrics, we have to take decision, because it's all about taking a decision. Do we have to manage the vulnerability today, or we just have to wait? Regarding this metrics, we have 4 suggested decisions. The first one is to do it now, to try to fix as quick as possible, and we call the right people to do it now. The second one is to try to correct this vulnerability as quick as possible, but we don't have we don't call people to, we don't wake people to do the job. And the next one is to apply the fix when the next patching contact, if you have this process, of course. And the next one, which is a lot of the majority of vulnerability, it's apply the fix if possible, because we don't have the time to follow the vulnerability, because we consider that as non-priority. I have a quick drill for you, so you can use the chat room to answer. An exercise. We have 3 vulnerabilities with this matrix, and the question is, what if you have resources for fixing only one vulnerability? Which one do you plan to remediate? So please give me 1, 2, or 3 in the chat room. maybe 2, 3. Okay. It's very depending of which are the main metrics you have to deal with. But I'm pretty aware with the 2. Yes, the 2. Why? Because the 2, it's not a vulnerability with a high score, a high CVSS by score, but it's exposed is a the vulnerable asset is exposed from the internet. We have a remote, we have an exploit which is remotely available, and the asset is the asset criticality is high. So definitely it will be the first one we have to manage them. But the real question is, where you don't have you have limited resources, but you have to deal with a lot of vulnerability. So how do you proceed that skill? We also have to talk about the exploit. We have, because an exploit it's not just a script. It could be a script or a message in a forum, a video, a blog post. It could be just a tweet to know how to exploit them. Everyone is sharing this this vulnerability, this data, this exploit. So you have to collect the data and to monitor a lot of feeds to know about the new vulnerability and new trusted vulnerability. Which the format, the feed, the maturity, the edge also to an old exploit could be more exploited, more used by more known and used by attacker. And what is the interest of this vulnerability about your assets? So this is a lot of caveats we have to deal with. To help us to do it, to manage the vulnerability and the metrics, we built by Patrol Hears, which is an open source tool to monitor vulnerabilities, to speed up the metrics updates, and to fill up the metrics, and to share vulnerabilities and metrics within our team. If we want to synthesize into one slide, it could be like this. As a vulnerability manager today and penetration tester, you always, if you have a new vulnerability, you only check on you check on NVD, exploit DB to have the vulnerabilities, Metasploit. You have to search in GitHub if if there are any available exploit which is not referenced by another website. You check on Twitter, Vilnius, exploiters, and so on. The idea of Patrol here is to make all this data available in a single cockpit and to manage vulnerability and exploit in a single platform. That's the idea. Basically, it's a vulnerability database, a vulnerability and metadata database. We collect vulnerabilities from NVD, so the CV, the CP, and the CWE the definition to keep the attribute tracking. We also try to inject CV-less vulnerabilities because there are a lot of vulnerabilities which are not the CVE. So, but we have to manage them and their related exploits. We also reference lots of exploits in a different manner. We don't always collect and inject the full exploit, but we reference, we keep the link to the available reference, the structures, and we also monitor security advisories and build them. It's basically a monitoring tower. So you have, if you want to use it, you have to know about the vendor, the products you have within your IT systems. And if you are a developer, the package you use, and you can use Patrol here to track some vulnerability changes. So if you want to be alerted if when a vulnerability, when a new exploit is available on a particular vulnerability, it's possible to. So it's a tool to share monitoring list within the teams, within multiple teams. We have a scoring system, but it's based on the CVSS scoring system. We have alerting with using the email or the Slack notification. At the beginning of the project, it was only an API. So every features and data is available through the REST API. We just make a quick responsive web UI to present the data and so on. So the global architecture, I will just go on this slide. Well, we'll talk about the open source contribution. Patrol here, we have all the source code is available on Twitter. The first one is Patrol here, which is the application, the backend and the front-end application. The web front-end is designed in Vue.js. The backend is in Django, which is a Python framework, database PostgreSQL. We use message queuing MQ system because we have a lot of asynchronous tasks. We use Celery and RabbitMQ to do it. And if you want to deploy the application, you can deploy it using like a command by Python application, or we also provide the Docker images and Ansible script to deploy it as quick as possible in your system. We also released the Patrol Here's data, which is the repository. You can find both the raw data, the raw vulnerabilities, and the script to update and load and to collect the vulnerability from the NVD and to inject it in Patrol Here. At the moment, the Patrol Here feeds, which is the repository, we have the script to scrap some data on packet storm, to enable exploit DB, ZDI, Cbug, and so on. We also we get vulnerabilities and exploit using the HackerOne reports. It's very useful and well right. We have a lot of data from this feed. We also provide an API client, which is in Python. Which is Patrol here for Py. You can use it like a switch to quickly access the vulnerabilities and their metadata. So if you want to test it and start it, please do. Everything is available on the Patrol here repository. The common user are mostly the IT security team, which is the CISO, the SOC, the DevOps. But basically, it's quite easy to use it, and it could be used by all IT teams. There's some caveat of this application. We are well aware of known limitation of the product. The first one is our basic source of the data is NVD, but we have a lot of the delay between the bulletin issued by the vendors and the NVD database. So it could be relevant a big delay between these two feeds of information. So we are working hard to make the integration with most of the vendor advisory bulletin. If the word would be very easier to use if all vendors have a single way to share their vulnerability. It could be a very good idea for us, but for all the community, we have to, because basically every IT corporation, or every corporation, every teams have to manage a lot of vulnerability. We just don't have always only the Cisco product or only Red Hat product. We always have to manage with a lot of technologies and vendors, but there is no major standard to manage this. We have a lot of initiative, but there is no leading part. We don't support SSO at the moment. We only focus on CVE and well-known vulnerabilities. We know that because we are European, we are French. The main source of information is the CVE from the NVIDIA emitter, but we have a lot of vulnerability coming from the Chinese, the Chinese and the Japanese community. So a good idea could be integrated the CNVD, the TNNVD vulnerabilities and the GPND vulnerabilities into a single platform, because the language is not a problem today. So this is the final part. I just want to share about how to prioritize the vulnerability. I think the most important thing is to focus on the contextualization of the data and to support it with automated scan. I think it's a good idea to do it efficiently, to do it simply and efficiently. We have coded and shared the patrol here, which is an GPL v3 license. It's basically designed for around an API backend. There is already a fancy web UI, but it's very useful if you use the REST API. And for us, it's like a lot of an open source subject. We have to animate the community, collect some feedbacks. It's very important to us, and to facilitate the integration with all the tools. So thank you very much. If you have any questions, so please shoot.
Thank you very much for your presentation. We have some time for a quick question in the Q&A if someone wants.
Maybe I have one. I don't think I missed it, but you did not explain in this presentation how to inject the data from your assets. I mean, I guess there is another product that will be used to scan the IT systems and to populate your assets database.
Yes, Thank you for this question. It's very operational. Yes, of course. You can the biggest part of the user is to know about the assets, which are the vendors and technologies they have into their. So if you know it, you can just select and identify the technologies. We also provide another tool, which is Patrol Manager. Patrol Manager is another open source project, which is a SecOps framework. With this framework, you can activate the inventory. So you can identify the technologies you have in your IT system using the scans, and then inject it into the patrol here's monitoring system. At the moment, this integration is not done. It's not a pro edition. No, it's just it is not coded at the time.
It's work in progress.
Yes, work in progress. But yes, but if you have the exhaustive list of technologies, you can use the API or just inject it in bulk using the CVSS file. But at the moment, we don't have the big integration between the inventory system or the CMDB or any inventory system to populate the technology to monitor into patrol here's.
Okay, thanks. I guess we.
Thanks again. Time is running, so we will move to the next one.
Thank you very much.
Thanks again for presentation. And we will welcome Michael Ham.
Hello, can you hear me and see me?
Yes, hello. So
Perfect.
Michael will show us a few forensics demos where things don't always go as expected. Michael is working on forensics incident response at Circle, the Computer Incident Response Center in Luxembourg. So the floor is yours. You can share your screen.
You see my desktop too?
Yeah.
Perfect. So hello, I'm Michael from Circle. Circle is a CERT in Luxembourg, and it plays also a role in the national CERT of Luxembourg. And yes, today I prepare some live demos. In fact, at the end, I choose 2 of them because the time is quite close and I like to show it precisely. So let's start with the first demo, which I called modify data on a read-only mounted device. So what's the story behind? Once a day, I read another forensic books. And in this book, the author stated, if you work with evidence, you need a hardware write blocker. Don't rely on software write blocker. Nothing will prevent your Linux system from modifying data if the device is mounted read-only. With this, I feel challenged. So I raised the idea to develop a small exercise where I simulate an attack, where I simulate to modify targeted data on the evidence, which are mounted read-only. So what I will use is my Linux onboard tools, and I will be root. And of course, it's a little trick. I'm curious how fast it takes until the first discover the trick. But I will not cheat. Yes, I'm root. I will not remount the file system in read-write mode. So this is not the trick. So yes, I prepare a small play script, how it could look. So there will be two phases. The first phase will be the preparation, where I connect my USB stick, where I remount the USB stick in read-only mode, and where I prove that I cannot modify the data anymore on the legit way. And then I will launch the attack. And the idea of the attack is I use strings to search the data I like to modify on the device. Then I will calculate based on the offset which sector the data are stored in. Then I use my favorite forensic tool, DD, to copy this sector on my local hard drive. And there I will modify the data. And then I use DD to copy this data back on the device. So that's the idea. And now let's see if this can work out. It's a live exercise. What can go wrong? This morning, one of the cheap USB sticks already broke. So I was happy to have time to image a new one. And now I connect it to the PC. Okay, it got recognized. It is already mounted, and we see there is one simple text file on it. Now let's investigate how the USB key is mounted to connected to my PC. So here we see obviously it's device SDC with one partition, SDC1. And it is mounted, SDC1 is mounted at Media Michael Circle DFIR. It's a FAT file system and it is mounted read-write. So I have to remount it in read-only mode. So now let's test or check if this works. SDC1 is mounted Media Michael Circle DFIR, and it's now read-only. So at this point, I cannot modify the data anymore officially. So let's test. Sure. Oh, it's on the different screen. So here the data I like to modify. I like to modify the word hello. 1, 2, 3, 4, 5, 5 times A. But as you see, I cannot save it anymore. I can save it on a different location, but I cannot save it anymore. It's read-only. Close without saving. Okay, so now it's time to search for the data on the stick. So I make my strings. I make clear first. Strings. Hello. So basically what I now do, I use the tool strings to search on SDC1 and grep for my string hello. So he found 2 times the string hello world at 2 different offset. And when I created the file, I used the tool VI, and the tool VI creates a temporary file. And then at the point when I say save, it creates the real file on the disk. So this is the offset we have to work with. So this is the offset in bytes. Now I divide this value by 512 because sectors are usually 512 byte size. So we have the sector 584. This should be the sector where our data are lying on the USB stick. So now my favorite tool, DD, I specify the input device. And block size is 512 per default, and there is some caps lock. So I skip the first 584 sectors, and then I write exactly one sector on the disk as file, let's call it 584.raw. So now we have a copy of the sector on our local hard drive. And now I cannot modify this file with a text editor. It's not a text file, it's a sector. So I have to use an hex editor, for example, to modify it. Hexa. Oop. So this is our sector. And here are the data we like to change. So we change it to 31, 32, 33, 34, 35. And we delete the other data. Now the file not even change in the size. Write it to disk. And yes, it's exactly the same. So now let's use td to write it back. So I tell td the input file is our sector. The block size is 512. We skip 584 sectors and write exactly one sector on the disk, and we write it to, and now this is a little bit critical because you can destroy your hard drive a little bit with it, def sdc1. I hope it works. Let's see what changed on the file. Okay, what do we see? We see still the words hello. So maybe it don't work finally, but wait, couldn't it be that this modification is so hot that the file system not realize it and provide us some file out of the cache? So let's throw out the USB stick. I connect it back. We have our file. We open it, and voila, now we have 1, 2, 3, 4, 5 world. So we successfully modified the data on the USB stick, even if it was mounted read-only. All the commands are in the slides, so you can reproduce this exercise on your own later on. I try some different commands to block or to stop this behavior. Basically, nothing else at the end. I try some forensic Linux distributions like Kali Linux or SunSift or Deft, DFIR. Some of them don't automatically mount the disk. Some of them only mount it in read-only mode, but modifying the data was possible on all the distributions. So my advice, use hardware write blocker. Okay. So the next exercise I like to show is called My Name is Legion. And here I prepare another USB stick. So kick off this USB stick and take the next one. I connect it to my Linux machine. And we have a USB stick mounted with 3 text files on it. So take a look, what do we have inside these text files? We have hello world. We have another ASCII art, and we have another ASCII art. Nice. So let's close this. And now I do something else. I take my Windows virtual machine and I connect the USB stick to this Windows virtual machine. So it disappears from my Linux box and now is popping up on the Windows machine. So what do we have here? We have our USB stick, we have our 3 text files, text 1, 2, 3. And now I tell you, this happens to me at one day when I was preparing a training and I have exactly this behavior. And now the content change. Oops. So pass the salt 2021, begin of text 1 file. Pass the salt 2021, begin of text 2. Isn't this spooky? You can imagine how I look when I saw this behavior. Okay, connect it back to the Linux. Stop. And here is our ASCII art again. So it's time to start analyzing what's going on. So let's first check how the stick is connected to the Linux machine. It's again device SDC1. So that looks okay. Now let's see how it is mounted. Okay, we have device SDC1 mounted as Media Michael Cyber Day 2020. Oh, looks good so far. Clear. Okay, let's take a look maybe at the partition table. So the tool fdisk find a partition table which starts at the sector, which is a very slow, just 57 megabytes. Oh, it's a slow partition. Makes maybe sense to have a slow partition on the USB stick. Okay, there's another tool to read the partition table, MMLS. Let's test what this tool says. Okay, I should. Hola. This tool failed to read the partition table. This is interesting because this is a very well-known tool to read partition tables, FMMLS. So if this tool fails, I have a problem. Then something is definitively wrong. And what I like to show you with this small exercise is you cannot only rely on your tools. At one point, when there is something special, the tools will start failing. And then you must be able to read bytes on a byte level, the bytes and words, to understand what's going on. Okay, I will now explain you what's going on here in this case. So let's check first the Linux, the Windows version, and our analyze steps. And now to understand what's going on, I like to go back to something which maybe some of you don't see for a long time. This is called a diskette. This is the successor of the floppy disk. Depending on the modulation, you can store 770 bytes or 1440 bytes on it. And then it depends how you format this diskette. But when you format this diskette with a file system, it is most common that the first sector on those diskette, the sector 0, is called the boot sector. Let's take a look in an easy boot sector. This is a boot sector which is easy because it is the boot sector of a disk which is not bootable. So this boot sector contains some metadata describing the disk. So for example, the label, and stuff like this. And it have some boot code. And this boot code, in this case, because those disk is not bootable, just have one activity to do, display the text. This is not a bootable disk. That's all. Maybe you remember on old times when you start to boot PC with a not bootable disk, you see this message, this error message, and maybe a peep tone. The interesting thing at this boot sector is that after the half of the value, after 250 byte on average, it starts to be empty. There are only zeros until the end of the boot sector, which have a signature, 55AA. So boot code at the beginning, the second half of the boot sector is empty. Then at one point, the disks get replaced by hard drives and USB sticks, which became more bigger. And what you have to know is you still can format drives like this old style without partitions. But since the drives become more bigger, people like to have more partitions on one physical disk. Yes, you like to have the separate root partition, a separate var partition, and separate, I don't know, etc partition, and so on and so on. So you need to have the concept of partitions. And how does it look? You have the partitions on your disk, and each partition consists of the volume boot record, which is basically the boot sector, and describing the file system on the partition. You have maybe some unused space in between and at the end and in between. And at the first sector at the disk, you have something new, which is called the master boot record. And the most important things of this master boot record is, first of all, defining where do the partitions start and how much sector it use. Where do the partitions start, how much sector it use. The second thing it describes, is this partition bootable or not? And yes, it must also, in case if this disk is a boot disk, it must execute some boot code, which basically read the partition table and jump to the first sector of the bootable partition and handle over the execution to this place. So now let's look to the next slide, where I have a master boot record of a disk which is not bootable, of my USB stick, which is just a data stick. And this data stick do not need any kind of boot code. It only needs the partition table and maybe some labels. So the partition table start at the end of the master boot record from here to here. And here you have the signature again. It's the same like for the boot sector. So this 64 bytes are the partition table. And here is space for exactly 4 entries, for 4 primary partitions. The first primary partition is defined from here to here. And here you have the value where the partitions start and how much sectors it need to use. And as you see, the second, the third, and the fourth partition table entry are empty. So we have our first partition here. This 07, for example, tells the operating system that this is a NTFS partition. And this 00 tells that it is not bootable. So, but let's go to the next step now. What I now did is I take the USB stick and formatted it as a unpartitioned USB stick with a volume boot record at the beginning. Then I created my 3 files. And then manually with the hex editor, I add a partition table entry. I add a partition table entry at the good location. And this partition table entry defines a partition at this place on the disk. And now I can format this partition table, this partition with NTFS, and I can create 3 files on it. And now it totally depends on the file system, on the computer, on the operating system, on the software. It depends. Do it read the master boot record value, the partition table, and access the partition, or do it use the boot sector and access this area of the disk? So that's the magic. So I'm quite in time, so there's also some space for question and answers if they appear.
Thank you very much.
Oh, thank you.
There are a few questions on the Q&A. I don't know if you can see it by yourself, otherwise, where is the question?
I don't. I check.
Okay, Axel is asking, what happens if your file is spanning on several sectors?
Can you repeat, please?
What happens if your file is spanning on several sectors? Maybe that was related to a specific moment of the presentation.
What is a good question is how do they coexist, those two file systems on one disk? The point is this volume is not aware. If you read the volume boot record, you are not aware that there is another partition. You don't know it. And if you fill up the disk with data, at one point you overwrite this data because the volume as is don't know that there is a partition if you only read the volume boot record. If you only read the master boot record, then you have full access to this partition. You can fill it up from the beginning to the end. Yeah.
Yeah, well, I think the question was related to the first demo.
Ah, okay. But I don't understand the question then.
Yeah. I guess even if the file is consists of several sectors, the strings command should report the exact offset. So this won't make a difference, I guess.
I go back to the strings command. Okay, here we have the strings command. Here I instruct the strings command to give me the offset of the string in decimal. So I know exactly at which byte position the hello world stands, what I'm looking for. And now only what I do is I copy this sector to my local drive, and then I copy the sector, I modify the sector on the local drive, and then I copy it back at the exactly the same partition. If you see here, I also skip again exactly the same number of sectors, and then I write this one sector exactly back on the place where it was before. I'm wondering.
Maybe the question was if your string happened to be on half on two sectors, then and two non-consecutive sectors, then you would not find your hello.
The string will find the hello and give me the offset. Just my calculation will a little bit fail if I, for example, if I take this offset for the H is the sector, and then let's assume the E already will start in the next sector. Then this will be the sector 585, where this continues. So the string will find this. Just if I make the DDD of one sector, I only will get the H at the end, at the last byte of the sector. And then I will discover that something go wrong, that I miss some data. In this case, I can cut 2 sectors to my drive. And then I can again modify it as it is in one each together. So strings do not stop after the sector and then say, I start new. It simply reads byte by byte, and so that's not a problem. This will not stop the attack. Do you have more questions? Ah, I see.
Yeah,
now.
there
I
are some
have no
more in the
access to.
Q&A. Ah, you have them? Okay.
Okay. A bit surprised there is no CRC on sectors. Yes, there is a CRC on sectors, but it's more low on the low-level partition formatting. There you have sectors. So a sector on low-level partitioning is more big than 512 bytes. You have a drive in to the sector, a sync part. Then you have some space in between each sector, and at the end of the sector you have the checksum, which calculates the checksum of the sector, but not of the content of the sector. So if the content, yeah. Good question. I'm wondering. Yes. No, it's below. It's below.
Yeah,
it's
you mean the way you write the sector will modify the CRC at the same time.
Yeah, it's low level. It's much more low level than the file system. And it is invisible to you as a user. You cannot access these parts of the sector. Okay. Have you tested some USB keys used to have a button to block write? No. No, I don't have a USB stick where I have a button to block writing. I'm sorry. Some people had some ideas, maybe try it with BSD. How does BSD handle it? Or is there maybe a way with those kernel level things in Linux, those SE Linux stuff? But I'm not, don't know enough to test this on my. Do you have a tool to create a polyglot master boot record? Yes, HexEdit. Yeah. The easiest is you create 2 disks, two USB sticks, one without master boot record with just 1 volume, and then you create a second one with a master boot record with a disk, and then you can use the hex editor to copy paste the values from one to the other. But you need to be careful a little bit because you have to take care not to destroy the master file table and some important stuff, which can then have influence to the first part to the boot sector. For example, you should not go to the end of the disk file because at the end of the disk there is again a mirror of the master file table and stuff like this. So you have to take a little bit care. Cool. Great questions. Thank you. If still time, you said you encountered it on the USB stick. I said it happens to me. Yes, I said I had this case one time, and I changed files on the data on the Linux system. Then I connected to the virtual machine of Windows, and I don't see the modification of the data. And I was struggling around for an hour until I started investigating what's going wrong. But it was myself. Because I prepare a USB stick for forensic training. And then at one point, FDisk crashed and I was a little bit bored and I plug out the USB stick and plug it in again. and create again new files with the same name. That was when it happens. And then I thought to myself, yes, I have to analyze what's going on. And if I can reproduce this, then I have a nice presentation. And I could reproduce it. There's also something in the chat. But no question. I cannot see a question in the chat.
There a question, where do we get the slides? So globally, we will collect the slides of every speaker, and we will share them along with the videos once we edit the stream to get it into several videos, and we will post it as usual on the Ubicast website.
If you want, I can also provide the disk images for the USB sticks so that you can play around with it.
Yeah, would be nice.
Just one advice to all attendees: if you work with DD and you are root user, take care. Better don't do it on your professional PC. It's very easy to destroy very important parts of your data or your operating system. Just one typo, making something to SDC1 instead of SDB1 or something like this, and you have a broken operating system. So great.
No more question?
And yeah, a little bit over time, but not too much, I think. No, still manageable. 5 minutes, 2 minutes.
Just perfect. Yeah.
Great.
Then thank you very much again.
Yes, thank you too for the opportunity.
And we will be back tomorrow, 2 o'clock.
Bye-bye.
Bye.
Goodbye, everybody.
Thanks to everybody. So we'll shut down the YouTube stream.